My name is Sam, and you are listening to endlessschool.com on the subject of basic sciences, minerals. Minerals have one basic definition. Number one is that they are inorganic, and second one is that they are natural. So if anyone wants to define the word mineral, they have to simply look at the following definition. It is naturally occurring inorganic substance. The characteristics of minerals are very simple. It is not factory made. It is not from a living organism. They have a very, very unique composition that cannot be altered. They have a very unique atomic formation, atomic formation. And finally, they are solid and not gas or liquid. So if anyone comes back and says, hey, Ivy just created some mineral liquid, they have two problems. Number one, you cannot make it because it's naturally made. The second one is that it is solid, not gas or liquid. If somebody was asking you what are the shapes of these minerals, you simply tell them the following. They have a cubic classification, tetragonal, orthogonal, monoclinic, triclinic, or hexagonal. In cubic or tetragonal, all you have to see is a square top or bottom. In orthogonal or monoclinic, all you have to see is some sort of a rectangular side. In triclinic, you need to see a parallelogram. And finally, in hexagonal, you need to see hexagonal shaped sides or base. So again, cubic, tetragonal, orthogonal, monoclinic, triclinic, and hexagonal. If somebody says, how are these formed? Where do you find them? Very simple. If you recall the magmas from the chamber, when they come out, either their interior or the exterior, minerals are embedded within the magma. Depending on how fast they cool, their formation and their rock structure is different. The other option is that you have a salt bed, the water evaporates, and what's remaining is halides. And these halides are known as salty crystals, that we consider them as minerals. So right here, as noted in my right here, or the precipitation through the salt, creating salt. Next, if somebody says, what are the classifications, what are the contents of these minerals, it's very simple. You have silicon, carbon, sulfur, halides, as I just described, and the oxides. With silicon as silicates, you need silicon and carbonate and sulfate, you need oxygen and metal combined with this three to give you silicate, carbonate, or sulfate. With sulfur, if you just simply add metals, you will have sulfite. With halite, you need either chlorine or fluorine plus metal. And then with oxides, you need carbon, oxides plus metal. So SCSSHO, or silicon carbon sulfur halide oxide, or silicate carbonate sulfate sulfide halide oxide gives you your classifications. Last item, if somebody is walking down the street with one of these minerals, how can you identify them? These identifications are hardness. If you consider diamond to be 10 and talc to be 1, halide sits anywhere between talc or diamond. That gives you what? A reference. As we all know, diamond is the hardest material. Or a specific gravity, which is the density with respect to the density of water. If that thing has a particular density, we could identify it. And generally, there are anywhere from 2 to 5, and we call them hefty. Heft is defined as very dense material, where the specific gravity is anywhere between 2 and 5. Fracture comes in by breaking, or cleavage comes in by breaking the mineral. If you break it and the surface becomes rugged or uneven, that becomes fracture. But if you break it and it becomes flat and very even, that's considered as cleavage. The streaks of color, and actually the color within the minerals, and sometimes the smell, is also another identification. But if you have streaks of color embedded within the minerals, and that gives you another identification. The last but not least is luster, and luster is actually, the definition is a French word for shiny. Lustre is the chandelier, where the metal minerals are very shiny, and non-metals are gray, dull, and pearl. Now, to go back, one more item, let me just scroll that down here, is that if you take the rock where the minerals are, and generally they're on the hills or the mountainside, you extract the ore through a process called smelting, where you melt it at a very high temperature, and you start sorting it by, depending on the classification that you said, density or gravity or centrifugal, or however they do it. With this crushed stone is put into a heated chamber, and then this pieces at high temperature heat, they start isolating them in a liquid form. Given that note, this is end of our minerals. But before we go, let's just practice one more time. Minerals are naturally occurring inorganic substance. They have 5 characteristics. They are from Earth's crust, not factory made. They are not from living organism. They have their own chemical composition. They have their own physical structure, crystal structure. They are also solid. Their shapes are cubic, tetragonal, orthogonal, monoclinic, triclinic, and hexagonal. They are either made within the magma or precipitation in a salt or a lake. They have silicate, carbonate, sulfate, sulfide, halide, and oxides. Their identifications are based on hardness, specific gravity, fracture, cleavage, streak, and luster. Given that note, please stay tuned for the other series in our science series. Thank you.